All right, so problem number 3, let's go ahead and see if we can get a table for this graph. So we want to graph u versus x. Let's get a column here. So when x is 0, u is 2. When x is 1, u is 4/3. When x is 2, u is 1. When x is 3, u is 2/3. When x is 4, is that right? No, 4. Sorry, this is wrong. When x is 3, u is 4/5. When x is 4, we get 2/3. And then, we're going to reach an asymptotic limit of 0, but I'm just going to go with this. And then when x is 5, we're going to end up getting 4/7. And when x is 6, we end up getting a half. So let's do this. At 0, we're at 2. At 1, we're at 4/3, about there. At 2, we're at 1. At 3, we're at 4/5. At 4, we're at about 2/3. And at 5, we're at 4/7. At 6, we're at a half. So we end up getting kind of a curve like this. This is going to be a bad graph, I'm just going to tell you right now. But, that's kind of the graph. Now we want the force associated with the potential energy function above. So for B, let's actually just do that calculation. So we'll do B and C. We'll do B right here. And I'm going to write this a little bit differently. U of x is going to be written as 4 times 2.0 plus x to the negative 1. So the force is going to be the negative derivative of that. So that's going to be negative 4 2.0 plus x to the negative 2. So my force ends up being 4 over 2.0 plus x squared. That's what I get for my force. And now we want to get the speed. So for C, let's go ahead and get that speed. We're going to have here, let's just use the potential kinetic energy function. So we have U plus KE equals total energy. So let's get the total energy. Now we're told that here it's released from rest at the origin. So that means all of our energy at the origin is stored as potential energy. Our energy at the origin is 2 joules. So we're going to have 2 joules equals 1/2 mv squared plus, and our energy at 2 is 1 joule. So we're going to have 1 is 1/2. The mass of our little dude is 1/2 kilogram v squared. And so we're going to end up getting a speed of 2 meters per second for part C. Now it says we're given a glider. The glider is acting by the force determined in part B. We want to determine the validity of our theoretical calculation in part C. So basically, we just want to figure out what the speed is going to be when the particle is at 2. So let's just see. We got a glider on an air track, and somehow the force is acting on it. So think of just a track like this, okay? Think that there's a little glider on it like this, and it moves down the track like that. That's how air gliders work. So basically what we're saying is that if this is 0, maybe the glider winds up at x equals 2, and we just want to verify that its speed is 2 meters per second. I would actually draw this on the AP. Okay, and then what I basically say is I'd want some different masses so that I could choose a 1/2 kilogram mass. I'd want a photogate timer, and I guess I'd want some kind of a meter stick so I could measure distance. So I'd basically verify 2 meters of distance. And I don't actually need the objects since I'm told I have a 0.5 meter air glider. So I'd want to verify the 2 meter distance, run the glider, and I'd use the photogate to time it and use distance over time to get the speed. Nothing more than that. So that's the third free response question, and I'll get to the multiple choice in the next video.